Alright, looks like we're good. We're good. Yeah, there we go. Audio's working fine. Alright. So, welcome to my little guide for Blender. This is going to be a basic introduction for UI elements, some core concepts, some tips and tricks, and a little bit of a deep dive into some topics about models in general, and more geared towards use for VR chat and models and assets in that way. So let's go ahead and get started. Go. For this, I'm going to be using Blender 4.2. You can use most versions of Blender. Will cover almost all these topics. But the general use cases here, most of this is going to work with almost every version of Blender. Some minor things might change, like the location of a button or what they look like, but the concepts are the same. So first things first, though, let's go ahead and go through some of our settings. So this is the default Blender scene. I have changed nothing about it. I've just started Blender up and go ahead and started it, and we get a camera, a cube, and a light. I'm not going to delete them, as most tutorials do. In fact, I'm going to be abusing the hell out of this cube. But let's go into our preferences. And there's a few key things that I'm usually going to recommend that you turn on. A couple of add-ons that are really worth having. One of them is Loop Tools, which provides you some extra flexibility when it comes to selecting things and moving things when you're in edit mode. As well as I like to have where is it? Align tools is somewhat useful when you're doing more complex things and trying to make sure that things line up perfectly. The Cat's Blender plugin, of which you're going to want to find the right version for your model, for your version of Blender, because there's a couple. We have some links in the server to a 4.1 and 4.2 compatible version. And there's other versions for older versions as well. But generally, I'm not going to recommend too many add-ons. I do have a bunch enabled here, but you don't need most of these. They're kind of specific use case. I'm going to switch over to the editing tab here. And one of the things I'm going to recommend is if you do any kind of weight painting at all, I'm going to recommend a custom gradient. So this down here, you can change what the colors look like depending on the weight values for weight painting. What I usually do is I have an option at position 0 that is just this bright shader broken pink, and then at the very next position I have the gradient starting. So this lets me see exactly where the weight painting ends on a certain vertice versus just having it fade to blue and then not really knowing where the delineation is. So that's something that I can recommend that you change if you want. Go into your settings and set that up. The next is going to be under your key map settings here. I highly recommend changing your spacebar action away from play to search. And this will let you change this action so that when you press space, it'll bring up a little box that you can type in a command name for, and it will just let you find it much quicker than trying to browse through menus or anything else. By default, it's set to play. Most of us are not making animations in Blender, so this entire section down here is fairly useless to us. But if you're doing animations, then maybe you want to leave it that way. The next thing, and this one's a fairly important one, is go to your System tab and look for your undo steps. I have mine set to 256. You should definitely turn yours up. I think by default it's only 10 or some very low number. This takes almost no memory to increase, and it provides you with a lot of back and forth on, say you've done an operation about 30 minutes ago, and you just realized that you really needed to do that a different way. You can probably undo all the way back to when you did that, as long as you haven't closed the program. So having a high amount of undo steps is very, very useful, especially if you're tinkering a lot and just kind of experimenting. So I'm going to go ahead and leave those. I'm going to make sure that you save preferences if you change anything, just to make sure they're actually set. And what's nice is once you do that, you almost never have to do this ever again, unless you change Blender versions. So you can pretty much just leave those as is. I'm not going to cover most of the rest of those since they're not really useful for our use case here. Next up is going to be the layout. So the things that Blender calls things is kind of different to some other programs, so the terminology helps a little bit in like determining where you are. First, you're going to have areas, and areas are these sections like this that I can resize, and they're kind of their own self-contained section of something. Like you can change what this area is. I can set this to a properties thing. or an outliner. So these areas here are the main work areas that you can have. And you can create and add and remove them. There's a very specific space right here. So if you see this cursor, then you can click and drag, and you can create a new one. And you can see how I can split this into half, and it will make two of them for me. And if I wish to combine them, I can click this again and do that and drag forward, and it will let me merge those two spaces. I can also split it vertically like this, so I can have two of them next to each other, and doing the same action backwards will merge them. You can also resize them, of course. You have here on the edges of them, you should be able to get resize bars, so you can change them here. You can't really drag them around, so in some programs you can drag the header. You can click here and like drag it around and snap it to different places. Blender's workflow is pretty much just if you need something here, you split that section and you make it just like that, and you set it up the way you want. And then if you don't need it, then you're supposed to merge them together like this. So you can also close sections. So if you right click in the header, you'll have the option to close area. So I'm going to go ahead and get rid of the animation section since we don't need that at all. So it just gives me more workspace to have in here. So you can use this to really customize your workflow. Say you like having multiple properties windows visible, so you can have more than one at the same time, and you can view different objects. It might be nice to have more than one of these scene outliners here, so you can see, like maybe you have one object with a lot of stuff under it and you want to be seeing that all the time. So that can be useful. Or having multiple views of your 3D port, like a side angle or a top angle. I know some older programs used to have a 4x4 split layout where you'd have top, side, and like forward, back, and side and front layouts, as well as your 3D view, which was like quartered down here. And some older artists really like that layout. I don't understand it, but people like it. But you can customize this as much as you like. And on top of that, you have these tabs up here, which are just different preset layouts for certain tasks, which I'll cover a little bit later, but you can see how they all have different layout arrangements and windows for different tasks. And you can even add your own and create custom spaces for whatever you're trying to do. Generally, layout, sculpting, UV editing, texture painting, and shading are usually the most important ones for most basic tasks within Blender. So those tabs are pretty well set up for what they're doing already, and you don't have to change much. Moving into the actual regions, so this section here is what's called a region. So inside this area, you have the controls for the actual 3D viewport. So I've got the 3D viewport selected here, and this top bar is your header for it. This will contain all the options and configuration things that you are using for that specific section. So in this case, I have access to edit mode, object mode, sculpt mode, vertex and weight painting, and all the good modes that you need in 3D view. So you can easily do that. I can also press tab, which by default will switch between object mode and edit mode. You can also set up in your settings so that you can press and hold tab and drag, and it will give you this menu to select which one you want to go to. So for now, I'm just going to select edit mode and then tab back to go back to regular object mode. In here, you're going to have different kinds of face modes. So if we go to edit mode, your bar up here will change. You've got context menus that show you all sorts of features that are designed for the space that you're working in. In edit mode here, you've got your vertex, your edges, your faces. So you can switch between each kind. So I can select just a single face, or I can select edges and work with those, or I can work on individual vertices, just the actual points that are in here, and do whatever I want. And of course, each one has their own menus, so you can do all sorts of things and operations with each. It can be more useful to know which mode you're in if you're trying to do certain operations. So like if I right click these now, the context menu will change depending on which mode I'm in. I'll get all these options that are meant to work with faces. Whereas if I press this one for edges and I select a couple edges, now my context menu changes completely to show me a bunch of stuff relating to edges. And same for vertex mode, which by the way, you can press 1, 2, or 3 to change these modes. And I can right click a vertex and I get all sorts of options for that vertex. Up along the top here, you're going to have your transformation and orientation and pivot points. So these are incredibly useful if you have an object. Let's switch back to object mode. I'm going to rotate this 45 degrees on the z-axis, just so that I can have a slightly different object space. So when you move objects around in Blender, or do any operations that involve moving a vertex or an object or anything like that, it is relative to its starting location until you apply it. So right now, it knows that this object, whatever shape it is rotated by 45 degrees on the z-axis. So it always knows that that is different from the main scene. So if I go in here and edit this now, and let's select this face, these options up here let me change how to move an object. So right now it's set to global, and I can press the G key to let me move an object, and I can lock it to an axis. So if I lock it to the y-axis, which is the green line, you'll see that it moves only left and right according to the 3D view, according to the global scene outside here. Now, if I change this to local, it will let me use the orientation of the face itself. So now if I press G and then Y, you'll see it lines up with the face as it's rotated. Now, because this rotation is not applied, this is different from the main scene. If I were to switch back to object mode, and then I can press Control A to bring up the apply menu, and I'm going to apply the rotation, go back to edit mode, and now I'm going to move this same space, local. I'm going to press G and Y, and you'll see now that it's lined up with the global scene because I applied the rotation. It's no longer different from the main scene. So its local Y is the same as the global Y, so you see no difference. Now I'm going to undo that because I want to keep that odd rotation. I'm going to undo until we're back to here. Now this setting up here for normal means that it takes into account the orientation of the object itself. So now if I press G to move and press Y, you'll see it's completely different because the normals that calculate are pointing in this way in the Y direction. This is more useful for when you're doing things like extrude or trying to move along the z-axis. So if I do this on global and press G and Z, you'll see it's globally moving up and down. Actually, let me grab it on here on the side. So G and Z, it wants to move straight up and down in the scene. If I do this on local, the local up and down is still the same. So it's going to do this, straight up and down. But if I click normal, the normal of this surface, the Z value, points outward and points backward because the flat plane, it's a dot product of all the faces. So if I press G and Z, it's going to move forward and back now. And so using these modes, you can change how all sorts of things happen. So I can select these faces, press G and Z, and you see that it's moving according to the total dot product of all of the things I have selected. And that's because the second option here. So the second option lets me pick what is considered the center point for whatever I'm working on. And I can set this to individual origins. And now if I do that, when I press G and Z, you'll see that each face has its own movement now. They're moving independent of each other. I can even pick two different faces facing different directions. Press Z, and you'll see that they move this way, combined. I can also select bounding box center. So what this will do is this will take, like, essentially, it draws a box around your selection in 3D. And whatever the center of that selection is the movement that's going to happen. So if I rotate, so press R, you'll see it rotates in this weird space. And I can actually visualize where that is. If I press Shift S, I can move the cursor to the middle of my selection, and it'll snap there. This is actually where it's rotating around, because that's the center of the bounding box. So now if I press R, you can see how that lines up the same. That's exactly where this object is rotating. So you can do all sorts of interesting operations like that. Moving here, we also have median point, which is usually the setting. So this is kind of the same as bounding box, except it's more meant for like a single, what do you call it? A single viewpoint, really. So it's gonna end up being the same most of the time as bounding box, except that bounding box is better for like larger selections that are spread around. It will pick the very center point. The active element here lets you select So you can rotate based on, or rotate or move, or whatever your operation is, based on the object that is currently selected. So right now, yes, I have two faces selected, but the active one is this white outlined one. So I can select multiple faces, and it's always the last one you click that becomes the active one. So now if I move along the X or the Y, it moves everything along that object's face. Instead of if I do the same selection, but it's the top one, and I do the same thing, now they all move along that axis. So this is one of those cases where in Blender, the order in which you click things matters, because the last thing you click is technically the selected object. So you want to keep that in mind when you're doing operations that rely on, say, merging. If I wanted to merge points together, so if I grab this vertex and this vertex, the white outlined one, if I merge these vertexes together, so we're going to go, let's see, where's my merge? I forget. It's on my Q menu because I use it all the damn time. I'm going to merge at center, or I can, let's see. I forgot where my merge is. It's here somewhere. Well, either way, I'm going to skip that because that's something for later.
Why don't you just use the search function that you signed?
You know what? You're right. Let's do that. Press space, surge, and I'm going to merge at last. So merge at last means it puts it onto the selected one. But if I merge it first, it should remember the last one I clicked, so it's gonna go there instead. So knowing which order of operations you have things selected will make a huge difference, which is why Blender delineates between just what you have selected and what the last thing actually highlighted is. Next up, we're going to have a little bit of...
By default, I think the M keys.
Yes, thank you, you're right. I forget about that. So yes, I can do this, and I can merge on last, like that, and it'll bring it to the last selected point. I can do the same thing here, merge at last, and it brings it all over there. The next thing is going to be the grid snapping and the magnetism up here. So there's all sorts of options for this. You can snap to an increment, which if you do the increment, it's weird in Blender. It doesn't snap based on a grid that you've specified. It snaps based on an increment from where the object is and the difference of where its center point is. So this is basically your pivot point. So essentially it is, if I set this to the median point, if I remember right. No, 3D cursor. We'll set it to 3D cursor. So it's going to be the difference of this length here, and it's going to snap to the next distance here, and the same thing there. So if I move this on the y-axis, actually, let's do global x. There we go. You can see that it moves this in this direction, and I'm going to turn on snapping with increment. And we're going to do the same thing, and you'll see it snaps by roughly the same amount. Actually, it should be exactly the same. And you can see how it snaps. I don't usually use increment unless you're doing like grid work, placing objects within a grid, and everything is pretty equally sized, or divisions of themselves, like 2 units or 3 units in width or whatever. But generally, the most often used ones, I don't bother with grid because it will snap to whatever your scene grid is, which can be useful for placement. But I recommend vertex for trying to line things up. So let's say I want to line up this vertex perfectly with these two. I want to move it in the middle, so I can press G to move. We're going to move it globally along the x-axis, and I'm going to snap it to the exact x value of one of these. And you can see I can hover over that vertice, and now it snaps to that vertice. I can even do the same thing here, so it's exactly the same, or over here, or here, or here. And once I do that, I can just click to leave it, and now it's in perfect alignment with those ones. It'll have the exact same x value. The other thing you can do is, I often do this for like lining up objects via their height. So I can grab something, I can do G and Z on the global, and I can line it up with something else like that. And now they're exactly the same height. You can also do edges and faces. So if you select edge, and let's say I try to move this vertex on the X, I can click an edge, and you can see how it tries to join somewhere along the start of that edge. And you can see it's kind of glitching out because I don't have very many vertices for it to work with. So it's trying to snap to the first part of that edge. However, let me undo that. I can also select face. And what face will do is it'll try to determine where the cursor is from the viewpoint of your camera on the face. So if I move on the x-axis and I put my cursor here, it's trying to snap to this face, but it doesn't like that. But this is very useful for when you're trying to perfectly align things. You can use these snapping guides to basically bring it right up onto something. Let me duplicate this. So I'm going to Shift-D, duplicate, and I'm going to move it on the x-axis over this way. Keep in mind this is still rotated 45 degrees, and you'll see I have it set to normal and the 3D cursor. So it moved on an x-axis to the object in this way. But let's say I want to line these up in edit mode. So let's grab the whole object, and I have this as my selection. And I'm going to make sure that it's the same height as the top of the block. So I'm going to turn on vertex snapping. I'm going to do G and Z to move it up. I'm just going to snap onto this. And, oh, I need to set active. So active element on Z. Oh, hang on. Global. Do active element. Yep. And make sure vertex snapping is turned on. And make sure this is my last selected element. And it should grab... Oh, it's being mean to me now. Okay. So it might be better if I do face.
Because they're not the same mesh?
No, that shouldn't matter. I don't know why it's not using the selected element. Hang on. Maybe because I didn't apply. So if I apply all rotations, so all transforms, and now try to move it. Z. There we go. Yeah, now it's snapping. And those should be exactly the same height. Well, I lied.
Classic Blender.
Classic. Of course it does. Of course it doesn't work when I try to show it. So, you gotta love it. This is one of those things where it does take a little bit of trial and error sometimes to figure out which snapping node you really need. But yeah. Anywho, I need to move on from that. So
yeah,
yeah. Let's get to talking about proportional editing.
We can cover that later.
Yes. So first, I'm gonna subdivide this cube up a little bit so that we have a few more vertices to work with. We'll bring it up to there. All right. Now, with this last button here, this is proportional editing. This lets you affect vertices around what you're working with in a certain way. So if I turn this on, by default, it's set to smooth, which is like a fairly smooth shape. I'm going to move this on the Z. Let me turn off snapping. And you can see that it affects the vertices around it, and I can use the scroll wheel to change the radius that it can affect. So I can affect the whole object, or a very small part of the object, easily just by changing the scroll wheel value. Now, I can also change the shape that this uses. Whenever you do an operation, usually you get this little pop-up down here which shows you the last operation you did and the settings that it used. So I can now go down here and actually change what settings that last operation did. So you can see what the different shapes look like when you use a different fall-off range. You have constant, which just any vertex that was affected gets the same exact transformation as what you just did. Then you have random, which I don't know why you would ever use, but it's there. It's great for, faking terrain if you want. Most of the time you're going to want to use these smooth options, though. But you have plenty of options here to choose how it affects things. As well as on here, you can turn on an option called projected from view. If I turn this on, then it will take the viewport as the circle. So if I move this down now, so wherever you see the blue circle, that's actually where it's affecting, instead of a radius around the object. So if I turn on projected from view and I do the same view, now it's just only the vertices that were within the radius of the original vertex that you started with. So this can be useful if you're trying to, like, say, make a shape in this object. Let me just turn this up. And I can divot the whole object like this. And you can see it looks like a big cylinder just dumped it down. But if I switch this to proportional, you can see now it only affects a few vertices there. You can also turn off, oh, there's the projected, there we go. And you can see how it's like a sphere from around it instead of the shape that it was when I looked at it from the side. It gets this all weird shape. So we'll undo that. So proportional editing, make sure that when you have this on, sometimes it is a common problem that when you use this, the circle is so big, you can't see it. And it affects everything. So it may not look like you're using it properly because the circle is huge. And there's not really a good way to tell other than just being zoomed out. And you can see that the circle is massive compared to the object. So of course it's going to move everything.
Alright, Major, we have a question from, we actually have 2 things from chat here. We got Kadaku asking, the scroll wheel setting that for that thing that you were just using does not actually work. Is it a setting I have to change?
So generally you have to be in edit mode. So almost everything in Blender is contextual. So you have to be in edit mode. You have to have this turned on. And it has to be set to any of these, honestly. But you can see the proportional size here. If you need to, you can change this down. It might be so big that you can't see it. And then no amount of scrolling is going to make it visible. So here you can see I can scroll in and out. And up in the top corner up here, you'll see when I'm in edit mode. You can see what the operation is doing, and you can see its size, where it says proportional size smooth, and the meter radius. You might want to check that your radius isn't so big that you can't see it. So scrolling up should make it smaller. Scrolling down should make it larger. Just like that.
He apparently sees the, I had to change that in the menu, so he can see the circle, he just can't scroll to change it. Okay.
Okay, that might be something that changed with a certain Blender. I can help you debug that later, but on Blender 4.2, I'm pretty sure that's a default for the scroll wheel to change the size. It's possible that it might be different on an older version or a different version, or it might have gotten unbound. I know in settings you can change some key map settings for how the mouse behaves. We'll go edit preferences. And I think on interface, it's one of these. Not input, key map. It might be one of these options here, I'm not sure.
Anyway, Kadaku will contact you for
follow-ups
on that. Secondly, we have Razra saying, don't forget to mention the favorites where you can add tools to your favorite list on the Q key. By clicking on add to favorite, it's so useful I can't live without it.
Yes, I actually did use that earlier where I pressed Q and you can see all my favorites on here from different menus. So anytime you see a menu item of any kind, anything in a context menu or in your right-click menu, you can right-click that item and there's an add to quick favorites menu. You can even assign custom shortcuts from here, which might be useful if you do something a lot and you really just want a keyboard. But add to quick favorites means that it just puts it into this Q menu. So if I press Q anywhere, it'll try to bring up all of these. And it ignores context. So some of these options you may not be able to use. So like right now, if I'm in object mode, oh no, it doesn't anymore. Look at that, they fixed that. It used to ignore context where it would just show every menu item no matter what. But now it seems to matter because the merge by distance, merge at center, those disappear because those are part of the vertex menu. And if I'm not in edit mode, well, I can't use those, so they don't really do anything. But yeah, anytime you see a menu item that you just use a lot, like anything, you could right-click and click Add to Favorites. Very, very useful. Okay, I'm going to move on to a few other things. So next up here is the overlays. So in the overlays menu, this little button here, there's a little drop down here, and you can turn on a few useful things. I almost always like to turn on statistics. It's very useful for seeing how many tries are in your model. Especially if you're exporting for VRCS, you definitely want to minimize how many you've got as much as possible without losing the shape of the object or whatever you're working on. But always try to minimize this value. It's not the end of the world, but if you start hitting millions of vertices, then you are running into a problem. So You shouldn't have a sphere that has 7 million vertices or anything egregious like that. Try to keep your count low as much as possible. It will help in the long run. So obviously this cube is just a cube, but if let's go back all the way through my undo history until we're back before I did there we go. That's really nice to having a big undo history. You can see now that there's only 12 triangles in this because each face is considered 2 triangles. Everything's a tri. So we also have the face orientation, and in newer versions of Blender, you no longer see the blue side if it's facing the correct way. So technically, this is the front of the face, and on the other side is the back face. This is the red side. If you see the red side, that means you're looking at the back side of a face. And most standard shaders in Unity, including the Quest shader, do not render the back face. They purposely cull it out. It's a way to save on resources when you're rendering any material. Poyomi and Mochi have an option to turn on rendering of back faces, so that's something you can avoid if you need to. But in general, if you run into this issue and you need to fix a face, so you can actually do is Control F, yeah, for the face. Oh wait, no, it's Alt N, I believe. Yes, for normals. So here we can flip the face, and you'll see that now that side is red. But if I go turn this off, it looks the same. You may not be able to tell just by looking at the model that a face is flipped until you turn on this overlay. So something to keep in mind, if something looks like it keeps disappearing or it looks like it's inside out when you get it into Unity, this is probably why. Check your normals. So I'm going to go ahead and undo that. We'll unflip. Let's see. Those 2 overlay options are some of the most useful ones. And if you want to do a really nice screenshot of your object and you want to turn off all the UI, you can just poof. There's no more UI now. You just get pure object with lighting. And we'll do that. Then next you have your X-ray mode, and this is useful for being able to see through the model. So like, say I want to grab this vertice and the one opposite without having to rotate my camera a bunch or there's a bunch of stuff in the way. I can just turn on X-ray mode, and now I can see through the model as if it were transparent. So I can just grab multiple vertices, and now I can do whatever I want with it and just mess up the shape. So there is very useful. Now, X-ray is weird in that it's meant to work only in edit mode, but you can leave it on and then go to object mode, and your object will stay transparent. So this I see sometimes where people are like, why is my stuff transparent even though I didn't set it up to be transparent? It's because you left X-ray mode turned on. And you can now turn it off, and in some modes you won't be able to click this button, which can be frustrating. If I remember right, if you're in like white paint mode, maybe not. One of these, I forget which mode it was, but every now and then it disables, and it can be annoying because it may be turned on and you don't want it turned on, and you have to go into a different mode, turn it off, and then come back. Next up, you're going to have your rendering modes. So I almost never see anybody use wireframe. It's maybe not that useful if you're working with just props and stuff, but I'm sure somebody's got a use for it. Most of the time,
it's very useful for finding rogue vertices that ended up flipping inside of a mesh. So
true, yeah,
it can be useful.
Yeah, you can help this use this to help find things that are just floating around in there, I suppose. Next up, you're going to have viewport shading, and this has options. So each one of these has this little drop down that you can change what the options are. By default, your viewport shading is just going to be this standard gray color. I see some people like to switch it to a matte cap, and Blender comes with all these default matte caps, one of which is this one, and that adds a little bit of color to it. You can also turn on cavity, and you can turn on this. So you can see there's like an edge here. It kind of highlights what the edges look like instead of making them perfectly cut. So you can also do that in studio mode, where you can see there's now a little bit of a highlight on the edge there. So that can be useful for when you're just working with raw geometry and not, you don't really have textures or anything yet, but you still need to see like where the curves are, where the lines are. So a lot of people like having that turned on. It makes it look like clay for some people, so, and they like that look. You can also change things to, instead of displaying the material, which right now the default material is just this blank white color with basic roughness. You can set it up to use the object settings, which would be here under viewport display. So you can set the color manually from here, and this doesn't export if you change this or and then export it as a model. This is only for Blender view. So this is just to differentiate it in the viewport. So if you've got a scene full of hundreds of objects, it's sometimes nice to switch to this view and tell which ones are solid objects and which ones are all merged together. You can use attribute, single, random, and texture. Texture, it just tries to pull whatever texture is assigned to the material, and it just shows the color part. It doesn't do any like rendering or PBR or anything like that. It's just the color of the texture, which there is none assigned, so it's not going to show anything. And then random will just pick a random color. It ignores this viewport display color entirely and will just assign a color at random to it so that you can easily differentiate it from other objects. So if I duplicate this object, you'll see it should get a different color. You can see there's slightly different colors. It might be more obvious if I do it again. Oh, of course, they're just going to be slightly different shades. Thanks, Blender. But yeah, it will be random, so depending on what you've got. I usually leave it on material, or you can set it to object if you are trying to organize your scene more. Next up is going to be the viewport shading. So this will try to take into account your material settings. So if I go to the material here, and I'm just going to cheat real quick and pull in a cube that I've got. So I'm going to import an FBX. Oh, that's export. Oops. Import FBX. I've got a cube that I made ahead of time that's got some texture on it. And we're just going to hide the default cube. I just press H to hide. And this is one that I textured earlier. And that kind of helps show the orientation of things when you're working with UVs. But in this mode, if I switch back to this mode, there's no texture on here. And you can see how if I switch over to texture, there's no like shiny compared to the original material. It's just whatever the default materials are for Blender, but it will try to pull the texture. But if I use this, you can see how it changed a little bit with the light, but I can adjust the roughness. I can bring the metallic way up, so you can see how it becomes shiny. It becomes cube versus just raw texture on this mode. So this mode will try to draw PBR based on your material, and we'll cover materials later. So this is useful for previewing how your scene should look with your properly set up materials and checking lighting and some things like that. Next we're going to move on to, this is the render mode. So this is something you may want to set up beforehand, is switch your render mode to cycles. And I'm not going to bother changing any of these settings for now, they're fine the way they are. But if you switch into render mode, it will try to take into account the scene's lighting and any camera, and it will try to render the object. You'll see it slows down a lot because it's doing ray tracing now. So now it's doing light calculation based on the scene and doing whatever it can. Since there's not really any good lights in the scene, there's just the basic one, you're not really going to see a good result until you spend time setting up lighting and cameras and materials and everything in between. So most of the time you don't use this mode unless you're like doing a final preview of something. So this is really useful for just checking sure that your materials don't suck. And this is really useful for making sure you're not stretching your textures. But I often leave this on material. Since I like switching between these modes, this for editing and this for previewing. So, but your workflow may differ. Moving on past that, we have some options that can show up on the left and right. So if you press T, you can hide the toolbar over here, and this is mostly used for the movement gizmos, rotating, transform, and scale. You can actually move your 3D cursor here, or you can change what kind of selection you've got between box select, circle, and lasso. You can select multiple things very easily. I usually leave it on just select box. Tweak is weird. Tweak is designed so that you click it once, and now you can do whatever you want. You don't click a second time. You don't do anything else. And I don't recommend it because you can accidentally be in, say, edit mode, and with tweak enabled, you might grab a vertice and then inadvertently move it just because your mouse moved a little bit while you clicked it. So I don't recommend having that mode on. Box is usually best. And then, of course, you've got your other modes here, and you can see that if you hover over them, Oh, it doesn't show. That's weird. Well, there should show a key, so I can press G to move. I can press R to rotate. I can press S to scale, so I can make it bigger or smaller. This might be better if I do this on a face. So R for rotate, G for move. Oh, that's control. S for scale. So those are useful keyboard shortcuts for just moving stuff around. Now, this sidebar sometimes gets hidden, so press the T key and that brings it back. But there's all sorts of other operations on here, so we can do things like we can extrude a region, or I can inset faces. So here I can now drag inward and I can create a new face here with more faces around it. And you can do all sorts of things. If I press E again, it will extrude again, so now I can make a shape. You can also cut and add lines, so this is loop cut. This will try to place a line all the way around it. It does its best. You can get some interesting results as you do so. Let me switch this back to edit mode so you can see those. And you can select these lines and do whatever. Then you have knife tool, which lets you just draw on the surface. And it does this via the viewport. So if I press enter now, it just cut all those lines into that face. Which sometimes is useful if you're doing really weird shapes. But generally you want to try to get to it from other modes here. Okay, moving on. We'll get back to where we were, object mode. Okay, on the other side here is all your sidebar stuff. So this is mostly where add-ons you install will add their tool menus. So you can press N to show and hide this side. And there's also this really tiny arrow here that you can use to drag them out. But this is incredibly useful for if you have an object and you haven't applied like its rotation or scale or anything else. So if I move this on the Z, we'll just scooch it over to the left. You can see now that because these are non-zero, it knows that this object was once here in the center. And like I said before, everything in Blender is done relatively, so it will know that this object has moved a relative amount of X this amount in this direction from the center of the scene. Now, if I go ahead and apply everything, all transforms, so location, rotation, and scale, you'll see that those get zeroed out, and this little dot gets moved back to the center of the scene, because now the object is technically, its center point is in the middle of the scene. It hasn't moved. It's always just been right here. So you can use this to see if something has unapplied scale, which is very important if you're trying to do things in edit mode. So if I scale this by 5, right? We'll make this a huge thing. And I then come in here and select a face. Let me get out of cut mode. And I try to do an operation on this face, like, let's see. Where is it? Oh, actually, the best way to tell it is the edge length. So if I turn on this little option here in the mesh edit mode overlays, I can turn on to the edge length and see it still thinks that the object is 2 meters wide, the original starting size, even though I just scaled it by 5. Because technically the object is only 2 meters wide, but the scene has it scaled by 5. So if I then apply the scale and then go back to edit mode, you see now it's actually 10 meters wide, because now we've got our scale. It's a 1-to-1 with the scene, and all of the objects inside now represent their real life size according to the scene. Now, this is a problem if you're trying to do certain operations on objects that have non-uniform scale. So like if I do like this, where I scale it, let's just set this to 10. So now it's scaled weirdly this way. And let's say I go in edit mode, I'm going to grab this face. And what happens if I try to scale this uniformly? It's going to do that. It's going to go all sorts of weird. But if I apply the scale again, and then do that, there you go. You can see it's a little more uniform. It matches the shape that it once was, instead of trying to skew weirdly in the one direction. So let me undo that and show you from the top, because that's, there you go. All right, moving on. So that is something to keep in mind, is make sure that your scale is zeroed out before you're trying to do any big operations on stuff, because that can really affect things. I'm just going to bring this back to center and then rotate it. There we go. Alright, moving on. Let's talk about the outliner real quick. So up here, it's just your layout of objects. So this is how you check how things are parented to each other, and this is again where the order of operations matters again. So let's parent these two objects together. So I'm going to make one a child of the other, and it matters which order I click, because the highlighted one over here is going to be the winner. So if I go parent, and then I'm going to hang on. Oh, I need join. That's right. If I click join, these become the same object, and you'll see that the one that stayed, the name that stayed, was the last one I haven't selected. If I want to parent them, so I can select these like that, and we can go do the parent move. Let's do just be parent make a parent object. There we go. Boop. You'll see now that it becomes a child object of that one. But if I do this the other way around, so if I select this cube first, actually you'll see the last one is the highlighted one. It's the other way around, and we'll parent object. You'll see now that the other cube won out and is now the actual parent. So this matters when you're doing bones, since you can change the hierarchy of bones and all sorts of things like that. This matters hugely when what order you have things selected. So go ahead and undo that. You can also see that if I expand these objects, it does show its properties under here. So this thing has all sorts of extra properties down here, which show up in the Properties tab, which is where I'm going to move to next. So this tab here has all sorts of settings and properties for the scene, for the project, for the objects. Here you've got, this is your active tool. So whatever tool you've got selected, it usually has options available here. They also show up here. You've also got scene options, so you can set up what rendering engine you're on, all the settings for that. You can set up what the output images are. There's their scene view here. This is how you change the units of your scene. So by default, Blender has everything set to metric with 1 meter units. If you really want to hurt yourself, you can go to Imperial, and you can now set everything to feet and inches. I don't know why you'd want to do that unless you're trying to do something one-to-one with like a house layout or something like that, and then you can later convert to some other unit. But by default, it'll be set to metric and 1 unit each. This is important later when you're going to export the object, because you need to set what unit scale it's at, and Unity will try to convert from whatever scale is in the file to Unity's scale. And if they line up, then you end up with an object that comes back in at the same size as what you exported, versus 100 times larger. So this is the important section for setting up your units. We're going to kind of skip over the rest of these because we don't really need these. Then you have your collection settings, so you can have multiple like folders for your objects in your scene. So you can have other collections, and you can turn these on and off to hide those objects entirely. You can also use this little eye icon to hide things. So if something gets hidden and you don't remember how to bring it back, which by the way, Alt-H unhides the whole scene. Anything that's not visible will be unhidden, but you can also manually do them over here with this little icon. The object modifier here, so the object properties, it's kind of the same as this setting over here. It shows you its X, Y, Z, rotation, scale values all right here as well. So it's just duplicated into here. You can also set things like your viewport display. You can do different shading options. Most of this is not really all that useful, but you can set up your viewport display and see whether or not the object's been moved using that menu. Next, you have your modifiers, and this is where things like the armature modifier, if you've got an avatar, this is where the armature modifier will be set up. This will connect a set of bones to your mesh, so that when those bones move, it tries to deform the mesh in some way. And that combines with, later down the road here in data, it'll combine with vertex groups to move stuff around. The next important tab, we can skip most of these. We're not going to use particles, we're not going to use physics, we're not going to use constraints. But those can be set up for all sorts of fun things later. For us, this is the next most important area. Almost always will you need to touch something in here. The vertex groups, shape keys, also known as blend shapes, your UV maps, and sometimes the color attributes. This is also known as vertex colors. These sections here are some of the most important sections for your model because this is how you define where the texture is. What blend shapes are available to you in Unity, how the mesh moves if you put an armature on it. That's what all this is for. I'll cover these a little bit more after I go through the rest of this, but then you next have your material tab. So this here lets you list all the materials available for this specific object. So in this case, the default cube has the default material with all of its settings here, and you can change them here if you wish, as well as this material. Now, this list here is the list of materials that are assigned to this object, but it doesn't necessarily mean that they're used. So I can add another material. Let's throw the default cube material in there, but it doesn't mean that it's actually used anywhere. You see, nothing changed. So what I can do is go into edit mode. I can select one of these faces, and then I can assign it here to that material. And you'll see now that that's fully changed. You can also use these buttons to select anything that is this material. So I can select that, and it'll automatically click. It'll highlight any objects for me. And then I can reassign them to another material like this. I can also use this to select everything or deselect things. So let's say I want these faces. Now there's just two of them. And I want to assign them to the default cube. All right. So let's say I want to invert my selection. So I can select that. And then I can Control I and pick everything that isn't that material. So now I can do something else with that, like assign it to the default cube. Now it looks just like the other cube. I can also just bring it all back, select everything, assign here. And what's useful before you export is you should click this little drop down here. This is some settings. And there's a remove unused slots. This helps clean up this menu so that nothing in here that is, if you have any materials that aren't assigned to any vertices, it will remove them. So this helps clean up that menu. It also helps you find like duplicate materials where you've got the same material listed twice, but it's assigned to different faces. You can use this to help shrink the menu down, and you can find where those are. They'll just be listed next to each other instead. Okay, going back up here. So let's see. Covering materials. So that is a quick overview of the properties menu. I'm going to cover some more of this in a little bit, but I'm going to move on to the next topic here, which is these different layouts. So these layouts here just contain different setups of the different windows, and you can use them for whatever they're designed for. Each one kind of has a feel that they're meant for. So layout is primarily used for like looking at things. It's kind of meant to be like the generic default preview. You could do anything here. It's meant to have a few extra things, so it's got your basic properties, your thing on the side, but it's not really meant for any one specific purpose. So it's kind of meant to be a blank slate for you to do whatever you want with. Modeling is more streamlined specifically for, as it says, modeling. So it removes the timeline at the bottom. It's really just got the properties here, and it's got a much smaller outliner on the top here. And the big, huge view is your modeling viewport, so your 3D view. Sculpting is designed to be in sculpt mode. It highlights your brushes. You've got your same kind of layout, but all your brush tools are already pre-selected and on the side and ready to go. And it puts you into sculpt mode right away, so you don't have to switch into sculpt mode. UV editing has this nice dual view, so you've got your 3D view here and you've got your texture view on the side here, so you can look at your textures compared to your objects and make sure. By the way, if you can't see all your bars up here, you can middle mouse click to drag left and right up here, and you can see them. And I can switch this back into preview mode to see my textures, and you can see how they assign to the texture. Texture paint is similar. It's a side-by-side view, and it's meant so that you can actually literally paint on the texture, and it will show up. So you do have to have textures assigned to your material to be able to do this, but you can paint on the model as well. This is extremely useful for like making masks. I recommend this very highly if you're just making simple masks. So it makes it a lot easier to paint on something. Just keep in mind that your UVs are going to highly determine, what kind of oddities you get. So make sure you have a good UV Shading here is primarily used for setting up your materials. So it's got this whole window down here for playing with the material nodes. It's got a texture preview. It's got a nice little folder browser over here for your files. And then, of course, the 3D view to show off everything. And these are almost always here. You have your properties and your layout. We're not going to touch on animation, but this would let you set up a camera. You can see the camera view. You can have timeline. Same thing for rendering. You've got the output of your camera view for the rendering. Compositing is meant for once you've generated an image, you can use the compositing view to add nodes and modify the image in some way or do other things. Geometry nodes is designed for the geometry node system that Blender has, which lets you programmatically change meshes and do all sorts of crazy stuff on the fly. It's a huge system that I'm not going to touch on tonight, but you could do ridiculous things with this system. It's very, very flexible. And then lastly, we have the scripting tab, which is kind of designed for writing Python scripts, which is what Blender runs in. So you can do all sorts of Python commands. You can automate tasks that you have to do 1,000 times. You can turn it into a script. There's all sorts of options here. You can usually view built-in ones. If you've got a script or something that you loaded in, this is where you'll be able to view what is in the project. And then lastly, you have the little plus button here, so you can make your own custom layout. And you can choose a template. It lets you pick one of these custom templates to start with, or you can just duplicate the current. I'm just going to click a general, do scripting. It'll double the scripting tab, and you can do whatever you want with this new layout and make it different. All your settings are different, and you'll see that it saves it. So very similar. There is a downside in that once you start modifying a layout, there's not really a way to revert it to the defaults unless you do a factory reset. Unfortunately, that's a UI thing that Blender just doesn't really have a good way to do yet. Maybe one day they'll make it easier to revert these layouts. So if you make big changes to one and you don't like how it looks, you pretty much have to reset it to reset your project to fix it. So for now, those are the tabs. Before we move on to the deeper dive context, I'm going to talk about vertex group, shape keys, some UV mapping, texture painting, shading, and export settings for stuff. So those are going to be a little more in depth, but I think this covers the general layout and where things are in Blender. Did anybody have any specific questions that they wanted to ask before I move on to the next topic? I'm going to give you a few minutes. I'm also gonna get a quick drink here. I think that pretty well covers most things that you're going to need. Just one of the things I want to really point out is be aware of your settings up at the top here, whether or not you're in global, local, or normal, what your pivot point is set to, because you can get some really weird operations. You see my 3D cursor is off on the side. If I set this to 3D cursor and then rotate, it doesn't rotate around the center of the object like you'd expect. It rotates around where the cursor is. So just keep in mind what your settings are when you're working with this kind of stuff, especially snapping and proportional. Those ones I see get turned on a lot and people don't notice until a problem is there. Okay, so there's some topics I'd like to cover, and that is going to be, we'll start with vertex groups. So if I select this object, this one here, and we're going to go to our data tab for our object, and we can see that there are no vertex groups. There's nothing assigned right now, but you can use these for all sorts of things. Vertex groups are essentially a list of vertices and a float value. So I can take these two vertices here on the edge, and I can actually create a vertex group. So I'm going to make one. I'm going to call this group test. You can name them whatever you'd like. The name does not matter until you're dealing with an armature. So what I'm going to do is then assign these two vertices. You can see, you can see this weight slider here. I'm going to set these to a value of 1, and I'm going to assign the test group to it. So now you don't see anything visually change. That's the downside to vertex groups. They're kind of hard to visualize. But what I can do, I can go into weight paint mode, and now you can see how it affects things. And it will be a gradient from full to 0, depending on the value of the vertexes. It will blend from one vertex to the next one that it's connected to. So you can see here that those specific vertices, go back to edit mode, have a value of 1 on them. Now I can also do like a half value. So I'll select this one here. I'm going to set this to 0.5, and we'll assign that to the group. Go back to edit, vertex mode, weight paint. There we go. Turn off the mask. And you can see now that it blends a little more based on that side. Now, this is useful for specifically armatures. So armatures work in the way that they are a list of objects that rotate or move. You're really just making blank markers that denote that they can move and rotate. So I'm going to go ahead and add an armature object here. So I'm going to add, you know what? Let's use the search menu, space, armature. And helps by, oh, I have to add a bone. What am I doing? Oh, I'm in edit mode. If you're going to add stuff to the scene,
yes,
be in object mode. Yes, that helps. That would be why I couldn't find armature. There we go. So I want to add an armature, single bone. Now let's just do single bone. Yeah, there we go. And it creates an armature object for me. And in here you can see there is just the one bone. So I'm going to use this bone. I'm going to grab the end here, which you can't see it because it's hiding inside the object, but it's there. I'm going to make a second bone. I'm just going to press E to extrude and draw a bone up here. I don't care how it's aligned right now, but what I'm going to do is name this bone. So I'm going to go out of that mode, I'm going to edit mode, select this bone, and I'm going to press F2 to rename it, and we'll call this test bone. Actually, we're just going to call it test, because that is the same name that my vertex group is called. So right now, if I go into pose mode, nothing will happen. It doesn't move anything, it doesn't affect any vertices, and that's because I did not connect these together. So this armature and this object are two completely different objects, and they're not connected in any way. Until I go here, let's go edit mode, object mode, select our cube, we're going to go to our modifiers, and this is where we connect them. We add an armature modifier. So this armature modifier takes an armature. You use the little dropper tool and click on the armature object. And what this will do is this will look for any bones in the armature that are specified that match a vertex group name specified here. So because I have a bone called test, it will take the rotation of this bone and it will apply math to all the vertices in that vertex group to try to match it. So if you remember, I made these vertices follow at 100%, so a value of 1, and this one 50%. So now if I select my armature and I go here to pose mode and I move this bone, you can see that those vertices will now follow along. And this is the most core concept of armatures in general, is that there must be the armature modifier on the object that you wish to change, so that would be your body mesh or something else, and there must be vertex groups that have the same exact name as the bones that they're supposed to follow. And that's how you determine what your weight painting is. So I can also do, if I select the armature first, mesh second, I can now go into weight paint mode, and I can select bones. If I hold control, oh no, shift. Was it alt? That's alt now. There we go. If I hold alt, I can select a specific bone, and it will recognize that this bone is called test, and it will select the vertex group on this object that I have called test. And now I can paint on it if I want. So I can set this to draw, set a weight. I can now modify these directly with a brush. So I can draw in here and do whatever I want. And now I can move the bone, and a lot more of the model follows along. So this is weight painting in general. It is a bunch of vertex groups that line up to a bone with float values for every single vertice that they affect, from a scale from 0 to 1. If it's 0, down here in the corner, these are 0, and I move it, they move not at all. They don't move at all. But if they're 1, you can see that they follow it exactly. So if I rotate here, you can see that they're 1 to 1 with the rotation of the bone. So this is how you do weight painting for pretty much anything. It's the core concept right here. Next up, we can cover. The vertex groups can be useful for weight painting. You can also use them for any other modifiers and stuff like that. This is just, it's a list of vertices with a weight value attached to it, so you can use it for all sorts of other things. If I add a different modifier to this, like say, let's add a bend modifier. Hang on, is it? It's one of the deform modifiers. Let's go deform, and it was simple deform. Here we go. You can see I do this fun operation, and it does it to everything right now by default. But I'm actually going to set, if I set restrictions, I can pick a vertex group that it's allowed to affect. Now, it'll use that vertex group, and you can see that the ones that are red are affected 100%, and the ones that aren't touched at all. And you can even see the cube of where they once were, and you can change the preview here. So if I click this little button, it changes the edit mode preview to match what the modifier is doing. So you can use vertex groups to limit how a modifier affects your mesh. So like say you want to smooth only a very specific area, you can do some weight painting, paint in a vertex group for yourself, and then apply your modifier to just that space instead of the whole model. This is essentially the core of how armatures affect everything too. Let's get out of weight paint mode, go back to object mode. So next up on our data tab, box, go. We have shape keys. Shape keys are pretty straightforward. So the shape key, when you create one, oh, let me get back to object mode. Let me hide these so they're not in the way. There we go. I'm going to make a shape key, and your first one is considered basis. You don't edit this. This is the original starting point for all vertices, is your basis. If I add a new blend shape, we'll call this, just call it test. This doesn't line up with vertex groups, so we'll just call it something else. Test F, whatever. So this has an application value from 0 to 1. As you're familiar with using them in Blender or in Unity, you can change the value here from 0 to 1. What this does is it stores the location of a vertice and applies it as a modifier to the original location. So whatever basis is, it remembers like, okay, well here's where the thing starts. Well, here's some math that moves it on the X, Y, and Z plane. So what I'm going to do is I'm going to go edit mode. I'm going to select this shape key, and I'm going to select one vertice, and we're going to move it out on the Y here. There we go, this way. Poof, just like that. Easy peasy. Oh, did I have more than one selected? Oh, I had that mode. That's why. We'll move it out like that. So single vertice out. If I go back to object mode, you see it goes away because the blend shape is turned off. If I have it move, you can see it's a percentage value. The 1 is all the way. This vertex gets moved to the exact location that this remembers it at compared to the basis. And you can't really change this mode in Unity, but in Blender you have the option to change it relative to another shape key. So right now, all shape keys are set up to be different from the basis. So I could then add another shape key and have it based off of this one, and it'll move there. You can't really set that up in Unity, unfortunately, so it's really only useful in Blender. But 90% of shape keys are just this. It's a stored location for that vertice to move compared to the original basis location. And it's always a percentage value. So if I move this, if I select this here, and we'll just move the vertice up this way, and then this way, so out here. And of course, same thing. It just stores the final location, and it does a percentage based on the original basis. Now, one thing that you shouldn't be using shape keys for is to drastically change the layout of a mesh. It's okay to use it for shape, which is kind of its name, shape key. But what I see a lot of people doing is like digigrade legs. They'll use a blend shape to change the legs into a digigrade, when that you should be doing that with bones instead of trying to do it with a blend shape, because the vertices, the way that they're affected, so you know I have my armature attached to it, right? Well, if I have my armature selected, and let's turn on that blend shape all the way, and then I move this bone, Oh, whoops, that's edit mode, pose mode. There we go. You can see how that vertex still follows 100% with the bone, so it amplifies how much that vertex moves. And it can be some really weird results if you're not careful. So generally, you don't want to use blend shapes to fully change the form of an object, but rather its smaller shape. So if you need something that would require extra bones, you should set up extra bones for them, and scaling and that kind of stuff. Let's see. There was one more thing. Shape keys. Okay, yeah. So with shape keys out of the way, I'm going to switch into UV mapping. So with UV maps, as you see, I have my nice little texture here. Set my material so that it's not metallic anymore. Turn the roughness back up. There we go. 0.5. I'm going to switch over to my shading tab for this. So this lets me see the node layout. And I'm going to be switching back and forth from shading and UV editing to showcase different parts. So let me make sure that I'm selected on basis. There we go. Now, as you can see by the texture, we call them UVs because X, Y, and Z were taken. X, Y, and Z is your location. And then technically there's UV and W, which we don't really use W. It's not really space efficient to use the W value, but technically W would be if U and V is the X and Y value of this cube, W would be the depth into the cube. And almost nobody uses 3D textures. It's a huge waste of memory to use 3D textures, so we just don't do it. But the specification is there, and so the first two letters just becomes U and V. Now, the space that you're working in is here on the left, and it's a 00 to 11 value. So it's a float value, just like most other things are. And it's always from 0 to 1. You can go further, and that's where you start running into the range of UV tiling, where you can have multiple sections outside here. Most things will expect you to be within the 0 to 1 range, and if you go out of it, some things can throw errors if they're not built for it. But as you can see, the values go higher as you go up, and they go higher as you go right. So they start in the bottom left corner, which can throw off some people because it makes sense if you come from a math background where you look at a Cartesian plane and the positive x is always going to the right and positive y is always going up. In some other systems, y would go down, or you might have x going left. So it can throw off some people who aren't used to that. But in general, this is your space that you work with for a texture. And really, it's just assigning this 3D point to a 2D space on the texture. So each one of these, if I grab this single vertex, so if I select this face, this is the upper top vertex here, right? I can grab this and move it inward, and you'll see how it stretches the texture to try to fit. It does all sorts of weird things, so I can like see just that part there. And it does weird things to the texture if you've got a non-uniform shape. But the idea is that, let me just undo that, there we go. You can map any texture to any part of the model so that you can have a nice unwrapping for it. Now, there's all sorts of techniques that come with unwrapping models and getting them to fit nicely into the texture. That is a deep dive for another day. But the idea is that you want to use these coordinates here, the 0 to 1, to put your stuff in. Now, you have options like down here in the UV maps, so this is part of your data set. This is the next section from shape keys. You can have multiple UV maps. The first one is almost always used for your raw texture and normal maps and any other textures that just need to be applied to the model, but you can have more. Blender lets you have as many as you want. Most programs will only look for 1 or 2. Poyomi will let you have 4. So will Mochi, if I remember right. You can select multiple UVs when you assign your texture. Unity likes to use 2. So your first one is almost always going to be for your color and regular texturing, and your second one is usually what's used for, there's multiple purposes, but Unity will use this one for light mapping. And that is just a raw texture with lighting data that's saved and applied to like the whole model. And it needs every model face to be in its own special space. It cannot be merged on top of each other. They can't overlap. They can't go outside the 0 to 1 range. They must be in this square. So if you wish to have a light mapped object, you can't have like this where I've got every square in the same space. What you can do to fix this is I usually just grab whatever the texture is. You can press A to select everything. I'm going to press Q. Have my favorites. I'm going to pack islands, but you can do this from up here. UV, pack islands. And what this will try to do is it'll try to fit all of these objects into the same texture space, but not overlapping. So I'm just going to go ahead and let it use default settings. Give it a moment. Wow, that's a lot slower than it should be. Oh, watch me crash Blender. You ready?
This is a good time to point out that whenever you're working with Blender, save often, save.
Yes. Here. Oh, there we go. Okay. I don't know why that took longer than it should have, but it figured it out. So it took every square and it moved it into its own special space on here. Now you notice that the texture on the right didn't change. Like it didn't actually move the textures because I'm not previewing that one. I have this little camera icon. You can switch which one it's previewed to. And you can see now that each face has its own unique mapping on the texture. This is important if you're going to do light mapping for an object or custom props or anything for a world. You need to have a UV that fits it within the 0 to 1 space for every object that's going to have its own light map. The other use that it's used for, and this is something that's unique to Poyomi, is UV tiles. So UV tiles can be set up so that if I edit mode this, I can grab one of these faces. Let's grab this face. And I'm going to shift it exactly one grid square to the right. So it's still in the same texture space. Actually, let's grab one with text on it. Let's do this one. I'm going to shift it exactly one unit to the right. So GX1. Oh, I didn't do it fast enough. Hang on. Okay. GX1. Poof. So now I'm technically in the repeating texture space, but you'll see that the texture didn't change. Even if I move it a little bit, it should move, right? But the texture hasn't changed at all because according to the GPU, the default settings for any texture is that it repeats infinitely in every direction. So no matter which way I put this, if I put this way out here, eventually it'll repeat and we'll get the same values. There they are. They're hiding up here. So that's roughly a few grid spaces away. But the way Poyomi does this is it uses this, if I select this now, to hide an entire section of the model by just discarding any UV that is in that space. So anything outside the 0 to 1, if it's within this grid space, you can turn it off. And then this mesh essentially does this. Oh, whoops, hang on. It's the top one, right? Yeah. It just does this. It just hides the face. It just doesn't draw it, doesn't render it, doesn't waste the GPU resources on it. It just gets turned off immediately. So this is a great way to hide objects, to hide clothing, to do all sorts of toggles for things. This is why some really optimized models, if you go look at the UVs, they're spread out all the way up in here. And the reasoning for that is because they're using UV tiles. Now, you can help preview this. Where is the setting? Oh, I think I have to go to the texture here. Yes, here we go, the texture. So it's, instead of single image, I'm going to set this to UDIM tiles, which is what Blender calls them. And that doesn't change much here, but on the side over here in the UV, I can pull this out, and I can add UDIM tiles now. So for the view, I should be able to, where was it? One of these lets me change the grid view. Hang on. Here it is. Okay, they moved it. It's moved a couple times, so I'm going to do fixed. I'm going to set tiles to 4 by 4. This is what we have access to in Poyomi. So all these grids constitute 16 different spaces that we can have. So we can have toggles for 16 different items within Poyomi that just work with the UV tiles. This is the space you can work in. So I can grab this face and I can move it GX1, GY1. Oh, whoops, that was scale. Hang on. GX1, right? GY1, and we scooched it up there. So in Poyomi, you have the option to choose which row and column that you're turning on and off. So this would be row 2, column 1. Or sorry, row, they start at 0, 0, so it'd be 1, 1. But this is how you set up UV tiles. They're just a duplication of the tile all the way over in these different grid squares. I think I'm going to move on from that. So the last one is, the last use for a second UV map is what's called a detail map. So I'm going to go ahead and delete this one. And we'll go back to the default. I'm going to unhide all my stuff. And we don't need that. So now a detail map lets you essentially have just a second mapping for the object. And what you can do is you can have a special texture that's only job is to tile and just look like high resolution detail, but it's actually a small texture that tiles a lot. And with a detail map, what you can do is you can have a wholly separate UV that is specially designed for that detail map. Some standard shaders in Unity let you use the detail map and understand that it's on the second UV, and you can't change what UV it's on. So it just automatically assumes you have a model with 2 UV maps, and it will pick second one. The Mochi shader, if I remember right, will try to use the second one if possible. And I believe the Quest shader as well also supports a second UV for a detail map. So you can specify all sorts of stuff there. You can have a wholly different UV map layout specifically for your detail. That's a less useful feature, but it is known about, and it's one of those things where if you know how to take advantage of it, you can have a much higher detail normal on an object than you normally could fit with just the texture map. So you can make it look more detailed than it actually is. Okay, did anybody have any questions on that section? Because I'm going to move on to the next one. I'm going to cover some texture painting real quick. Alright, I don't see anybody typing, so... Alright, moving on. So, with texture paint in Blender, the default way to do textures is very, very simplistic. You can specify in your material that it has a texture for the base color, and this is what you can draw on. So, in this mode, you get some brushes, you get some colors. You can draw with your secondary color by holding Control, so I can draw... Oh, hang on. Can I? Oh, I'm not even in the right mode. Hang on. Let's do Object, Select, Texture Paint, thing. There we go. Why can't I draw? Gotta love it. It doesn't take much to be able to mix it up.
Is it because the primary is... There you
go. What's weird is I should be able to paint on this side. I don't know why it's not letting me. Oh, you're right. The primary. UV map. Oop. Nope. I love Blender. Brush mode, right? Weird. I don't know why it's not letting me paint. Oh, it might be because I had this set to UDIM tiles. Let's try back to single image. Yeah, okay, that's what it was. Anyways, so I find that this mode is it's an extremely simplified version of like Substance Painter. You can draw directly on the model with brushes, and you can paint colors in. You can't do layers. You can't do complex modifiers. You can't do like stencils very well. There are stencils, but they're very cumbersome to use. I find that this setting is most useful when you need to make a mask. You need the 3D object, and you need to be able to draw a shape on it that is useful for like an emission mask or to show a certain thing. It's really useful for generating black and white texture masks. So generally what I do is I will unassign the texture to the material. So we'll just close that. We'll make a new one in whatever size we're going to use. So I'll just do 2K, 2048 by 2048. I'm not going to let it have an alpha channel. We don't need the fourth color channel, which is alpha, but we are going to start with a black color, so no color at all. And we'll make new image. And you'll see we get this nice brand new black image. The left doesn't change because it's still looking at our original texture, so we have to go here and actually select it, which it's called untitled because I didn't name it. But now I can paint on this texture. So see, I could draw over here, and we have this area here. Now I can't draw on this too well because you'll see that my UV map is like the same for everything. This is where detail normal would come in useful. So if I perhaps made a second UV map, right? We go to our UV editing, have that selected, and let's just let's do that unpack that I did, pack islands. Oop, we'll let that happen. Oh, I didn't select everything. Pack islands. So that everything gets its own unique face. Well, I don't know why this takes longer than it should for that. It's just squares. Give this a moment. But I can, once I have a second UV map, I can basically draw on that second UV. Eventually. There we go. Alright. So we'll have this selected and visible. Back to our texture paint. And now you see that the UV over here has changed, so I can draw on individual faces. So I can make a die, right? There. The world's best dice. So I could then save this image now. So on the left here, since this is a generated image, it technically doesn't exist as a file yet. It's all saved in memory currently. So until then, I can go save as, and I can export this as a texture. So let's go throw this in my example cube folder. We'll call it dice mask. And we can save this all with default settings as a PNG. And what I can do now is switch over to Unity real fast. And I've got the cube here, and I have this nice material set up for it already. Oh, whoops, I can't edit that one. Let's throw new material on there. And I have my dice mask, and I'm going to throw it in the base color. And you can see how it doesn't follow the second UV because I have not told it to. So this is Mochi. I can go into render settings, or hang on, where is it? Here we go, UV set 1. Go. Well, it didn't change. Why didn't it change? That's weird. Oh, because I didn't actually export the model. So I didn't save with this. So let me do a quick export. We'll do export. Bump, bump. Cube. Default settings. Save. And we'll fix the model. There we go. It's going to be up there, rotated.
Get rotated, idiot.
Yeah. It's because this cube here is the one I want. Exported everything, because whatever. Anyways, moving on. You can use this to specify special detail maps. I'm just gonna skip that part. That'll be for a later date. Just know that you can have extra UV maps. The last thing I want to cover is some vertex colors. So this can be useful for making advanced masks that are on the object itself, essentially. So it's like vertex weights, the vertex groups up here, where these ones only store a single float. Vertex colors or color attributes store 3 values. They store 3 floats, essentially a color. So you can color this red, green, or blue, and you can use that as if it were a multi-channel mask within Blender or Unity. And it's very useful to be able to create colors. So older systems used to use vertex colors to draw colors on models without using a texture at all. You would just specify what color that vertex was, and it would paint it on that whole face. And it was an extremely fast way to draw models with simple colors. You couldn't have any detail in the texture. It would just be a fade from one color to the next, which is why a lot of early graphics, like old PlayStation games and stuff like that, or old Nintendo 64 games, didn't really use a lot of textures on their models. They used vertex colors. They would just paint each color on a vertex, and then the GPU could quickly draw it. They didn't have to look up a texture. They didn't have to add extra memory. They didn't need more VRAM. Nothing. It was all just part of the data that came with the vertex. So it was very, very fast, and still is. If you don't need a texture on your model and you just need it to be a certain color, you can use vertex colors instead, and you can specify that in your shader, and it will be incredibly fast. Let's see. Let's move on to setting up some shading, so in PBR materials. So I'm trying to move a little bit quicker here because we're getting on close to the hour-and-a-half mark, and I know people's brains are probably starting to get fried at this point, but I do want to cover some basic setting up of your materials. So by default, the Blender materials are very basic. Let's go to the other cube, go object mode, hide this one, default cube, come here. And we're gonna, you can see it's been moved. I'm gonna put this back where it belongs. Boop, there we go. And we'll go to our shading tab. And here we have the standard default material, which is the principled BSDF. This is a really easy way to do basic PBR or physically based rendering. You only need a couple textures. You need a color, metallic and smoothness, and a normal map. Those are the most basic forms of PBRs. You need those four materials roughly. For things like Unity and Blender, for VRCS specifically, you don't really need much more than that. In fact, I don't recommend trying to go in more depth other than color, metallic, roughness, and a normal map. Alpha if you need cutout. But for the most part, those four textures will cover almost every use case you could have. So I have some textures. Let me pull them in. Let me get to my folder real quick. I had it open and then I closed it. Let's just do this because I had them here. So show explore. Right. So I'm going to drag in each color. I have the albedo. So there's that. There is the metallic. Oh, there's the metallic. I'll grab the roughness. And I have, where's the normal map? All right. So a quick way to set up these materials is just to hook them up. So for color layer, we want to just drag base color. For our metallic, roughness, and normal map, these are data textures. They're not meant to be colored. They're not meant to be shown like colors. So these, we need to mark them as non-color. So if they're set to sRGB, there's some math behind the scenes that tries to convert the values in the file to something that displays better on your screen. But these are meant to store data. They're not meant to look pretty for us. They're meant to be exactly as they are represented in the file. So we want to set these to non-color. And I'm going to drag this one into our metallic space, this one into our roughness. Now, a thing to note is that Unity uses smoothness in its default shader, whereas Blender uses roughness. They are exactly the inverse of each other. So if ever you need to use a roughness mask and all you've got is smoothness, just invert it. There's usually a checkbox for that in Mochi and in Poyomi. If you need it for the standard shader, you're going to have to take it into an image editor and just invert the image. For the normal map, we're going to drag out one here. And we're going to add normal map normal. This is a custom node that takes a color as well as a strength value, but we just need the color value from here, and we're going to plop it in there. And now we have this nice textured brick, just like that. And you can see how it fits on there. It gives us this nice look, and the depth of it comes from our normal map, so it fakes the lighting around the objects. And you'll notice that it's still perfectly flat. There's no actual geometry change here. Yes, there's a certain character waiting underneath to crush this thing, but generally you don't want to pump the normal. You don't want to pump the normal strength up above 1 because you start getting weird lighting artifacts. But again, your roughness value plug in, your metallic values plug in, and this is just a really quick way to set up some PBR materials. You really don't need much more than this. For preview and stuff like that, so we can go over here. And you'll see that in this mode, I don't get any of that. Even if I switch to texture, all I get is like whatever the last texture was, or whatever it's selected, I believe. If I click this one, nope. Okay, it's just whatever. I don't know why it's picked the normal map. But anyways, you can see it tries to preview based on whatever texture is available. And then this one does the whole rendering step, and then we can switch over to viewport shading, which will try to use the lighting in the area to actually do stuff with it. It looks a little more realistic. So this is useful in Blender only for previewing your stuff, to make sure that your textures look fine. So like, if you're in edit mode here, and you're moving vertices, you can very easily end up stretching your textures, which doesn't look very good. And so a way to prevent this is in your options here. You can turn on correct face attributes, and we can move that, and you'll see that it tries to shift it in the UV space now, instead of leaving it alone. And I actually go to UV editing and select everything. You'll see that it's stretched that one square over into this other one. And you can actually watch it happen. If I grab it here and move it back, and then select everything, you can see how that has shifted everything to try to match where the texture actually is. So, that back. So something to keep in mind if you're trying to change the model, but you don't want the texture to warp. Now this really only works if your texture is repeating. If you've got one that's designed for your model and you move these vertices, then it's not going to look good. I think that's that for the shading section. I just really wanted to cover setting up nodes. I suppose I can cover if you've got combined masks where you have multiple channels stored in one texture. I'll have to make one of those real quick. Let me just do that. And Thry has this beautiful, cool tool called the Texture Packer. So this lets you take multiple textures and combine them into a single. I'm going to take the metallic. I'm going to take the roughness. And this is a common setup for metallic and roughness, is to have metallic on the red channel and your roughness or smoothness on the alpha channel. So I'm going to grab the maximum, we're going to throw it in here. Add max, we're going to throw it in here. And then those are going to be 0. And you'll see we get this partially transparent texture. Choose a folder to save this in. Cube. And we'll call this metallic smoothness. Oh, caps lock, love it. Okay, and this is a great way to create less textures for the same amount of data. So I'm going to go ahead and save that. There we go. And now you'll see down here I've got a metallic smoothness texture, which I'm going to drag directly into Blender. Oof, like this. I'm going to replace these two textures with that texture. So instead of just plugging directly into metallic and roughness, I now need to split this up. So we're going to do a split, or it was separate. That's what it was. Yes, separate color. Boop. And now I can grab specific color channels from this. So make sure this is set to non-color. And I know that my red channel is tied to metallic. And I know that my alpha channel is tied to smoothness. So I can just put that into the roughness value and we'll get the same result. So one texture lets us have multiple masks stored inside it. I even have space for 2 more masks. I have red and green channels that I can still use. And you can set that up all in here. You can add other textures in here and pack it all together. And Thry and Mochi will let you use this texture, and I can even use this in the standard shader. So if I pull out this one here, and that's the Mochi one, standard cube. Here we go. So if I pull the standard cube out, I can use this metallic and smoothness map here because the default settings let you pick the metallic alpha or the albedo, which is your main color texture. But this is designed for this exactly. I can drop that texture in and I'll have that there. We throw in the albedo. Oop. And then we throw in our normal map. Oop. There we go. Make sure that's set as a normal. And you'll see we get a fairly good result. The standard shader does an okay job. Poyomi does other options as well, so does Mochi, but like this standard method of texture packing means that you can save on texture memory. You're not loading in 2 textures, you're loading in 1, which also decreases your file size. So just a very nice, useful feature, and you can test it here by making sure that everything's packed correctly. Okay. Last thing that I want to touch on is the export settings for your models. So before I just kind of dumped everything out and exported it, and I got this. I have a weird result in here as a problem. So what I'm going to do instead is I'm going to select our cubes, and one of them has an armature, or is trying to have an armature, but I need to reparent this. So the one that has the armature, I'm going to move it underneath this object. So make sure object first, armature second, and then I'm going to click join to combine them. I can also rejoin here by holding shift and drop it in, and then drag it one more time to move the actual object into that collection. So one parents it, the other one actually puts it in there. And then I have the cube underneath my armature, as well as the default cube from Blender. So I'm going to go ahead and export. So we'll go File, Export, FBX. And something to keep in mind, let me close this for a sec, is our scale. So right now, our standard cube is set to 111. So is the armature and the default cube. So all of these are going to match what they look like in here. So the default cube is a 2 meter cube. It's not the Unity default's 1 meter cube. So you can see here on the grid, it covers 2 grid spaces. It's technically 2 meters across on every side. So I'm going to select everything. I'm going to do export. Overwrite my example cube. And here where I'm setting, I have these drop down presets here. So these are just a list of these options that are saved as a preset. So I can pick this one and you'll see that one of my settings changes. This is where your apply scalings comes in. So this matters if you're replacing an FBX for an avatar. What you need to check is whether or not the armature scale, so this object, not the top level object, this object, you're checking the scale value here. If it's a 1, then you want to be using the default units of Blender and FBX all. FBX all will mean that it'll be a 1-to-1 scale from Blender to Unity. It's 1 meter in Unity is 1 meter in Blender. If you set this to all local, then that scale is changed by 100, a factor of 100. It'll be one unit here is essentially 100 centimeters in Unity. So you end up with an armature scale of 100 instead of 1, which means that all of your fizz bones and other things that are attached to your armature have to be divided by 100 to be the right size, because they'll be too huge. They'll be massive. So if you've ever seen that problem where you look at an avatar or try to edit it and the colliders are absolutely massive, it's because somebody replaced the armature with the wrong scale. So here I'm going to be using my preset. I love using armature scale 1, so I want FBX all to apply the scene scale, and I'm going to export that. Now if I go back to Unity, you'll see here, let me go click on the cube, make sure it's all the same. That on, boop, boop. Alright, so if I add in the Unity default cube, so I'm going to 3D object cube, there you go. Let me zero this so it's all in the same spot. You'll see that it's exactly half the size of the one that I exported, because the Unity cube is a 1 meter cube and my cube is a 2 meter cube. So you can see how they're working just fine. Now, this can be affected if you have an unapplied scale. So if I go in here and let's scale this by 0.5, so it's a half size, right? And then I go export again. Example cube, boop. We go back to Unity. You can see that the scale is the same, but it also knows that this object is half scale. It still says 0.5 on it instead of a scale of 1. It's not zeroed out for me. So what that means is if I go in here and reset this to 1, it's going to go back to its original size. So sometimes you want that, sometimes you don't. If you want this object to have its original scale to be a 1 when it comes in here, then you need to apply it. So even in Blender it says it's a 0.5, so I have to go apply scale. Now it's set back to 1, and now I can export again. So let's just export. And now that object is scale 1 versus my other object. So they're both their original scale size, but you can see that it's actually exactly 1 meter, and it matches. So this is how you can replace objects in Unity, by keeping the same scale, and not having everything get spaghettified when you do that. So just something really worth noting is to know what your unit scales are. So that's here in your scene settings. Here we go. Scene unit. By default, you want metric, unit scale 1, and you want length to be in meters, so that when you export using those settings, they are 1-to-1 with Unity. So whatever size it is in here, whatever scale it is in here, it will translate directly into Unity for you. I think at that point, I think this is a good point to call it, because it's getting to be on 9:30, and I think I've covered a fair amount of topics.
Yep, we've got coming up on 1 hour 45, so we've got about 15 minutes for Q&A. So if everyone wants to ask a question, you can go ahead and do so.
Anything at all. It doesn't even have to be specifically related to what I just covered. So if you have anything that you'd like answered, I will answer it now.
Yeah, anything about a blender. Or importing into... Very funny.
So a lot of you joke about you should be ready to make a AAA game by yourself. You joke about that, but these are core concepts to being able to do anything in the gaming industry. Basic PBR materials, working with vertex groups, working with armatures, knowing how to set up your scene scales, prepping UV maps for certain things. Like if you're building a world, you need to have light map UVs, and sometimes you can't rely on automated tools to make those because they don't always do a good job, or you need a very specific texel density, which is not something I covered, but texel density is essentially how much of the texture is used for this surface versus the other surfaces. So sometimes you want a higher texel density on a certain part of your model compared to other parts. Like say you have a mountain, but you could only see one side of the mountain versus the other side, and you could never ever see the other side. Well, that whole side of the mountain could have an extremely low texel density, and no one will ever see it. Hell, you could probably even get rid of it entirely, and no one would see it. But you can have an object that's like only ever meant to be viewed from one angle and can't be viewed from any other. You can make sure that the front side gets the most texel density for your light map. So you can have a custom UV specifically for that object, which says that, hey, these three faces, hang on, let me go object mode. So it could say something like, these three faces get 80% of the texture, versus these three in the back, which no one will ever see, get like, I don't know, a pixel. So you can have a custom light map specifically for making sure your scene looks pretty. You can really optimize in that way. As well as things like knowing about color attributes. Vertex colors are extremely useful for building masks into your object. You can use the red, green, and blue values. You can use them in Poyomi now as a mask value. So instead of painting a texture that is a black and white texture or trying to make your own things, you can actually bake things like normals into your vertex colors. You can do some pretty crazy optimization steps using that. And because vertex colors are extremely fast, they're much more efficient than loading in another texture and using the UV to interpolate what the pixels should be, because it's all built into the vertex data instead. So it can be done in a very faster way than loading in a whole nother texture. So knowing how to optimize in those ways is hugely important in the gaming industry, because you need them.
Every step makes it better. It makes a better experience.
Mm-hmm.
The little shit will pile up, as it were.
Yeah, and using things like vertex groups to help mitigate how much a modifier affects your mesh. Stuff like that can just be a big time save for the most part, and a lot of doing anything is how much time can you save, while getting a good or better result. So
that's something I'd like to point out in when dealing with anything to do with VR chat. You often see people going around being like, oh, check out these 4K textures and all that shit. It's like, oh, well, you don't need those. People, like, the visual fidelity of a headset cannot really display those 4K textures at a distance of more than a meter anyway. So you're wasting, so much fucking...
Yeah.
I shouldn't swear, but you're wasting so much. You're wasting so much, like, visual memory just because you want to look amazing up close. It's really not.
Yeah. So
going to be that.
At most, like this is kind of off topic, but at most you want to be trying to aim for 2K or smaller.
Mm-hmm.
90% of the time, most masks you need can be about a quarter of the resolution of your base texture, and they'll still work exactly the same, and you can't tell the difference. But knowing how to set them up and knowing how to like take advantage of that kind of stuff while you're working on the model can be a huge time save later if you try to optimize.
Yeah. Optimization starts at the creation, basically.
Mm-hmm.
Because if you start like building a highly detailed model, and you keep going from that, and then you decide 30 hours later, oh, I need to optimize this, you have to basically cut corners at every bloody point just to make it somewhat. Whereas if you decided from point one, you'd be like, okay, I'm going to design this as 2K textures from the start instead of 4K or 8K or God forbid 12K.
So Unity can't go above 8K, by the way. So
yeah, I figured, but
actually, I think I might be wrong on that. I think the newer version of Unity can go up to 16K. Let me double check. Yeah, you can do 16K now. Yeah, but that's not usable for most things. So the amount of VRAM that takes is ridiculous. But
AJ asks, I was messing around with Blender, so I didn't actually see how you view the grid in the faces, so you can mess with the vertices on the face of the cube. Okay, so that wasn't creating a grid. Well, it was, but it was more subdividing it into lots more different faces.
So what I had was, it's not a grid that was displayed on the model. I subdivided the model. So I went to, you can do this on the edge view, and go subdivide. And what I did was I'm literally creating more vertices, and I could just create even more. So you can see how each one of these is 0.2 meters across. Let me turn off the length so you can see that better. But yeah, I didn't draw a grid on here. I just subdivided until there was a grid, and then you can see that there's no visual difference outside of it.
Yeah. So with that, you can then manipulate each vertex or edge by itself. So yeah, one thing that I think we may not have covered is like the use of actually having grids like this. It's like, so you can do things like this where you can mold things.
This can be more useful in
sculpt mode.
Yeah, this can be more useful in sculpt mode. So sculpt mode is kind of designed for high resolution modeling. That is, so you see I've got a grid here, but this needs more. I'm going to subdivide this again. Let's do by 100. I don't care. It's going to take a second.
Jeez.
I'm probably about to crash Blender with the 100.
Yeah, you're about to crash. 100 cuts on top of 4. That's like what? A billion?
That's fine. There we go. Perfect. All right, so let's get out of edit mode. Just for curiosity's sake, let me turn on stats. There we go. It was 6.12 million vertices here, but now I can sculpt at about 3 frames a second. Maybe 100 was too much.
Yeah, I would have gone 10.
But look how smooth it is. Look how smooth it is. Oh, it's so smooth.
Yeah, look at the frame rate. Look at the frame rate, Aja.
It's okay. Don't worry about it. But anyways, yeah, sculpting is more designed for like high resolution stuff, and then eventually you would bake this down into a lower poly model. So you definitely should not be using your sculpts as your finished product. But this is a great way to bake in details to a texture. So like you could start with a flat plane and just draw all sorts of like handles, nuts and bolts, and cool stuff like that, wrinkles. And you can bake those into a normal map, which you can put on a flat plane and make it look like you had objects on there instead. I'm gonna Control Z until it's that. There we go.
Yeah, so an important thing to remember though is with sculpting and all that kind of things that each individual like vertex is its own point that you can manipulate.
Mm-hmm.
So if you drag a sculpting tool across a flat plane, for example, nothing's going to happen because there's no vertexes to sculpt.
Yeah, so you can see here it's
Because
moving all of these vertexes around.
Yeah.
But if I had this on, let's unsubdivide this, right? Go back to where before I had it. Boop. There we go. And now if I try to draw on it, ain't gonna happen much. See, I'm moving one vertice.
Yeah, because you can only move vertices.
Yes.
So if you wanted to sculpt like a thing onto a side of a wall, unfortunately, you'd need to subdivide the wall to make it so you have things to sculpt into.
I have seen a lot of people make textures that way. So you can actually procedural textures. You can sculpt your model. You can bake it down to a texture and turn that into something that's usable.
Go ahead, in the regular AJ.
Game.
Yeah, this is a Q&A, so
yep.
Okay, how does one properly export a Unity package? Now, I have a question for you, and this is important. What do you mean properly export? Do you mean like export a Unity package to give it to someone else, or to just like, is it a?
I think I can answer that. So,
okay.
If say you're exporting an avatar, I recommend saving everything into a scene, and then go to your project browser, find your scene file, and you can right-click on that and click export package. Now what this will do is this will pull all the references of any objects in that scene, as well as the scene itself, any models, any textures, anything that is necessary to load that scene will be included in here, so long as you have include dependencies turned on. A thing to note, if you've got any scripts at all in your package, it will pull every script in the project because they're considered dependencies, so that might be a problem. If you're exporting an avatar to give to someone, generally just export the scene and that's fine. If you really need to give them the whole project, you can export the assets folder. You can right click that and go export package, and it will pick everything. It won't pick your packages. So packages you should not be exporting anyways. You should be using Creator Companion or external tools to manage those. But this one will let you pick every file in the project that is included in the assets folder, so you can send the whole thing that way, and it puts it into a single file, a single Unity package. The perks of using a Unity package is that it's essentially a zip file with the meta files stored in it. So you can do it to any file within your project. So you can just right-click anything, and you can do export package, and it'll try to pull any dependencies it might have. So like it's a model that's got a whole bunch of stuff specified, or I could just turn that off, and it'll be only that object and its data for importing. So this is a great way to get files between projects and keep their settings, especially if you have a lot of them. It's also a good way to hand out an avatar that you built. Just put it all into a scene, make sure it's saved and clean, and then export the scene, and then that should be enough. Okay. Anybody else?
Is there anyone else? Yep. No problem.
All right, since it's 9:45 now, I think it's been exactly 2 hours, so I'm going to go ahead and wrap up the stream here.
Mm-hmm.
Do that. All right, thank all of you for coming along. If you have any questions, you're always welcome to ask at any time in the Discord. I'm always down to help and answer questions. This is going to be published on YouTube later with chapters and everything, so we'll have that there. And I want to thank everyone for coming along. So I'll see you at the next one, where I'll be covering some Substance Painter fun. So all sorts of cool things. All right.